Alright. Warm up. You randomly draw a 2 of diamonds from a standard deck of 52 cards. Without replacing the first card, you randomly draw another card. What is the probability that the second card is a diamond? That's right. Remember, we already pulled a 2 of diamonds out. So, the total of diamonds have dropped to 12, and the total number of cards have went to 51. So, keep this in mind. This is what conditional probability is all about. This event affected the second one. What was that called again? That's right, dependent. So, how can I understand, calculate, and interpret problems involving conditional probability? I don't know if any of you played this game before about drawing straws, but if you pull the short straw, you probably have to do something unpleasant, like climbing into a dumpster. Okay, so your friends will get together. It doesn't have to be straws, it could be sticks, or toothpicks really. It's just a matter of something you can kind of hold in your hand and draw straws. Thing you've seen in movies too. But naturally, as long straws have been drawn out, without replacing, the likelihood of you pulling the short straw is affected. As you can tell, it went from 1 out of 6 to 1 out of 3. You're increasing the odds for you if you've gone last in the drawing. So typically, you want to go first when drawing straws. Probability speaking, of course. So conditional probability is the probability that an event will occur based on the condition that another event has already happened. If you wanted to write that down, pause the video, go ahead. Boop. The conditional probability of B, given that A is the probability that B will occur based on the condition that A has already occurred. So, in this is how it's written, but mainly it's the point that we're pretending that, event A happened first before we even calculate what B might be. Okay? So here's what that probability statement up here is saying. B given A. Pretend that A has already happened. Now find the probability of B. So, you randomly draw 2 diamonds from a standard deck of 52 cards, kind of like the warm-up before. Without replacing the first card, you randomly draw another card. What is the probability that the first card is a 2 of diamonds and, remember that means to multiply, the second card is a diamond? So 2 of diamonds, there's only one card that's like that out of the 52. And if we said this happened, then we need to multiply by that second card being a diamond. If we're down 1 less diamond, that means there's only 12 left. And since we're down a card anyway, that means our total went down to 51. Ooh, I got to sneeze, excuse me. Never mind, false alarm. Multiply that out. Let me get my handy dandy calculator. Just winging it. I think it's 1 over 221. Let's see if I'm right. Boop. Nailed it. So here's that one card, the first one, 2 of diamonds. The diamonds went down, the total went down. Again, and it means to multiply. And we get 1 out of 221. Excellent. Boop. So we have a formula. Notice the probability of A and B equals probability A times probability B, given that A happened. If that's the case, then by dividing each side by PA, we get probability of A and B happening divided by probability of A equals the probability of B given A. This is that conditional probability formula. So remember, if A and B are independent, the events then, probability of A and B equals probability of A times B. But in this lesson, we're talking about dependent events. We kind of discussed that earlier. So here's an example. Boop. A math teacher gave her class 2 tests. 25% of the class passed both tests, and 42% of the class passed the first test. Both first. What percent of those who passed the first test also passed the second test? Okay. Both and. Do you remember I said those words rhyme? So if you're writing this as a fraction, you'd want to put that both number, 25, got to write as a decimal when we're doing that. You got to convert the percentage to a decimal, over, well, that first test, A, first letter in the alphabet, just trying to make it easy, 0.42. Grab your handy dandy calculator, which, I don't have the calculator because I'm using my laptop at the house, but I'll just use Desmos graphing calculator. So 0.25 divided by 0.42. I get somewhere on the lines of 0.595. I think I'd round that to 0.60. Boom, let's see if I'm right. Well, seem to have forgot the decimal, but yep, that's the right fraction, so I win. I got it right. Boop. There's another one. A jar contains black and white marbles. 2 marbles are chosen without replacement. Right there, keyword, without replacement, just dependent events. Probability of selecting a black marble and then a white one, black then white, is 0.34. The probability of selecting a black marble on the first draw is 0.47. 0.47 first draw and 0.34. Okay, just highlight some keywords here. What's the probability of selecting a white marble on the second draw, given that the first marble drawn was black? That's right, should be 0.34 over 0.47. And if you notice, especially on the last one, the smaller numbers on top and the bigger numbers on bottom. Why was that from the earlier discussions? That's right, probability needs to be between 0 to 1. If I were to flip this, it would be greater than 1, and then that's not okay. But again, still following the formula here. Let's see, I'm going to go ahead and off-screen calculate this. 0.34 divided by 0.47. Get 0.72 for kicks and grins. Oops. 0.72. Let me erase this. Let's check. And bam, got it right. Remember, if you wanted to write this as a percent, you move the decimal over twice. If you want to move this back to a decimal, move it to the left twice. Keep that in mind. Boop. The probability that it is Friday and that a student is absent is 0.03. Since there are 5 school days in a week, the probability that it is a Friday is 0.2. What is the probability that a student is absent given that today is Friday? Yep, that's right. 0.03 above 0.2. Get 15%. Which is probably typical because a lot of students like to take an early weekend. Beep. Think we're good here. Boop. So if you want to get that worksheet out, I think we're almost done with this. Just going to be about 10-15 minutes. In New York State, 40% of all teenagers own a skateboard, and 39% of all teenagers own a skateboard and rollerblades. And see the keywords here, just a skateboard. Highlight that because that goes with the and. What's the probability that a teenager owns rollerblades given that the teenager owns the skateboard. So, skateboard on bottom, 0.48. Both, 0.39, using our formula from earlier. Get my handy dandy calculator. 0.34, 0.39, excuse me. Divided by 0.48, we get 0.81. 0.81. Or if you wanted, 81%. In middle school, 18% of all students play football and basketball. And 32% of all students play football. What is the probability of students play basketball given that the students play football? That's right. And 18%, so 0.18 over 0.32 equals, let's see, going off screen to use Desmos, 0.18 divided by 0.32, enter, I got 0.56. 0.56 could be written as 56%. Boop. In the United States, 56% of all students get an allowance, and 41% of all children get. Did I say students? Holy cow! Let me just read this again. In the United States, 56 of all. I'm getting tongue-tied. In the United States, 56% of all children get an allowance, and 41% of all children get an allowance and do household chores. So 41%. Let me just got that 56%. What is the probability that a child does household chores given that a child gets an allowance? So allowance on the bottom, 56. And chores, allowance and chores, 41%. Using my handy dandy calculator, 0.41 divided by 0.56, and I got 0.73. 0.73. Or again, 73%. In Europe, 88% of all households have a television. 51% of all households have a television and a VCR. And for those of you who don't remember what VCR is, they play cassette tapes. Or VHS tapes is probably what I should have said. I don't know if any of y'all ever touched a tape. What is the probability that a household has a VCR? Or maybe I should change this to DVD. Maybe y'all know what that is. Given that it has a television. So, we have the word and again, so 51% on the bottom. Whoops. I didn't put that in the right spot, did I? Boop. Both and stuff goes on top. Television, 88 goes on the bottom. There we go. If I did it the other way, that would not have worked, because that would have been greater than 1. So, use my handy dandy calculator, 0.51 divided by 0.88, and we get 0.579, the 9 rounds to 7, so 0.58. I got 0.58. And try to draw a straight line, but I couldn't. Try that again. Boop. That would be 58%. I think we got one more. In New England, 84% of houses have a garage. And 65% of houses have a garage and a backyard. I remember having a backyard. What is the probability that the house has a backyard given that they have a garage? So 0.65, 0.84, using my calculator, and we get 0.77. Again, as a percent, 77%. I guess that's it. Have a wonderful day.